Chapter Cycloalkanes. Introduction. The cyclic hydrocarbons having carbon-carbon single bond or bonds and have general formula CnH2n are called cycloalkanes. They are also called polymethylenes due to the presence of methylene group CH2 group in their skeleton. The cycloalkanes come under the category of aliphatic cyclic compounds, that is, alicyclic compounds. These are so called because they possess cyclic structures and shows resemblance with aliphatic compounds in most of their properties. They are also called carbocyclic compounds because their ring skeleton has only one carbon atoms. Nomenclature of cycloalkanes. Common name. The name of any saturated alicyclic hydrocarbon is written by attaching the prefix tri, tetra, penta, hexa, etc. to the word methylene according as the number to carbon atoms in the ring, that is 3, 4, 5, 6, etc. respectively. IUPAC name. The IUPAC name of the organic compound contain the following parts: secondary prefix, primary prefix, word root, primary suffix, and no secondary suffix. Now, rules for the IUPAC name for alicyclic compounds. First, add prefix cyclo to the name of corresponding straight chain hydrocarbon. Second, the position of the substituent present in the ring are indicated by the Arabic numericals, that is 1, 2, 3, 4, etc. During numbering, the lowest number is given to that substituent whose prefix comes first in the alphabetical order, provided that it does not violate the lowest sum rule. Third, A part. If the ring contains more or equal number of carbon atoms than in the substituent attached the ring, then the compound is named as a derivative of cycloalkane. B part. If the substituent attached to the ring contains more number of carbon atoms than in the ring, then the compound is named as the derivative of substituent. C part. If, however, more than one alicyclic ring is attached to a single chain, then the compound is named as a derivative of alkane irrespective of the number of carbon atoms in the ring or in the chain. Fourth part. If the substituent attached to the ring contains the multiple bonds or the functional group, then the compound is named as a derivative of the substituent irrespective of the size of the ring. Fourth rule. If the multiple bond and some other substituent are present in the ring, then the numbering is done in such a way that the multiple bond gets the lowest number. Fifth rule. If the functional group is present along with some other substituent in the ring, then the functional group gets the lowest number. Sixth rule. If both rings as and the side chain contains functional groups, then the side chain or the ring containing principal functional groups will act as a principal chain. If, however, the alicyclic ring and the side chain contains the same functional group, then side chain or the ring containing more number of carbon atoms will act as a principal chain. Seventh rule. If any alicyclic ring is directly attached to the benzene ring, then it is named as a derivative of the benzene. Eighth rule. If the ring contains functional group which has carbon atom directly attached to the ring, then the carbon atom of the functional group is not considered in numbering. Ninth rule. If there are more than one functional group attached on the ring, then one of the group is considered as parent and other is named as a substituent. 10th. IUPAC name of bicyclic cycloalkanes. The hydrocarbons and their derivatives contain two or more rings are called bicyclic cycloalkanes. The carbon atoms common to both the rings are called bridgehead atoms, and each bond or chain of the carbon atoms connecting both the bridgehead atoms is called a bridge. The bridge may contain 0, 1, 2, etc. carbon atoms. The bicyclic compounds are named as find the name of alkanes by counting the total number of carbon atoms as in the two rings. Secondly, add the prefix bicyclo before the name of hydrocarbon. Third, find the number of carbon atoms in each of these three bridges, connecting the two bridge head carbon atoms and indicating by Arabic numerical. Now, arrange these Arabic numerical in descending order and separated from one another by full stops and enclosed in square brackets. And place these bracket Arabic numerical between name of alkane and prefix bicyclo. If a substituent is present, atoms of bicyclic ring are numbered. The numbering begins with the one of the bridgehead atoms. Proceed first along the longest bridge to the second bridgehead atom. Continues along the next longest to the first bridgehead and is finally completed along the shortest path. Methods of preparation of cycloalkanes and their derivatives. The important method for preparation of cycloalkanes and their derivatives are discussed below. First, Freund's method. Dehalogenation of dihalogen derivative of alkane. When 1,3 or 1,4 etc. dihalogen derivative of alkanes react with metal, sodium or zinc, they get dehalogenated to form cycloalkanes. For example, when 1,3 dibromopropane react with metallic zinc, cyclopropane is formed, or when 1,4 dibromobutane react with metallic zinc, cyclobutane is formed. Note: this method gives good yield only for the preparation of cyclopropane. If terminal halide is present at 1,5 or 1,6 carbon, then reaction forms open chains alkanes. Third, this reaction is comparable to internal Wurtz reaction. Fourth, the reaction proceeds through the formation of free radical followed by cyclization to form cycloalkanes. Second is Dickmann's condensation. It is an intermolecular Clancy condensation which occurs in esters of certain dicarboxylic acid such as adipic acid and pymalic acid. When ethyl adipate is treated with sodium ethoxide, cyclic beta ketoesters 2-carboethoxycyclopentanone is formed, which on hydrolysis followed by decarboxylation forms cyclopentanone. The ketone then on reaction with zinc amalgam in acidic medium that is HCl undergoes Clemson reduction to give cyclic alkenes. When dimethyl pymylate is treated with sodium dust or sodium alkoxide, it undergoes intermolecular Clemson condensation to form cyclic beta ketoester. The cyclic beta ketoester on hydrolysis followed by decarboxylation yield cyclic ketones which on reduction with the zinc amalgam and concentrated hydrochloric acid form cycloalkanes. Now, mechanism. The reaction occurs through following steps. Abstraction. First step, abstraction of alpha hydrogen by the base to yield carbanion, followed by internal Clancy condensation to yield 2 carbathoxycyclohexanone.